Okay, so 2-3 is the attributes of absolute value functions. We're going to be talking about their domain and range, as well as their intercepts, their vertices, their vertex, and their axis of symmetry. So if we go to Desmos and we look at the parent function on a graph, here we have the parent function, f of x equals the absolute value of x. And you'll notice a couple of things. For example, whenever I input negative numbers, I get positive numbers out, just like we would expect from an absolute value. And we get this unique feature where if we take the line y equals x, it's kind of like the same thing, except only half the graph. So really easy to plot. All you need to do is draw two diagonals. We can use the point 4, 4 and the point negative 4, 4, just to get my two lines, and these will go on forever, to the left and to the right, which means, of course, that the domain is all real numbers. Okay, it goes out forever, left and right forever. The range, up and down, it does have a minimum. So to write the range, we would say that it's all the y values greater than or equal to 0, because that is the lowest point, aka the minimum of this graph right here. Okay, we call this the vertex. For the parent function, it's at 0, 0. For the intercepts, the x-intercept and the y-intercept are going to be the same, since it crosses both axes right here at 0, 0. It does not cross any other time. The axis of symmetry, I'll draw this in. Essentially what this is the line of reflection for the parent function. So if we reflect over this red line, we should get the same thing on both sides. Okay, and this is what we call my axis of symmetry. Okay, this is the line x is equal to 0. If you type that into Desmos, you will see that x equals 0 will be your line of symmetry. And you can always use Desmos to check when you're writing those things. One last thing I want to emphasize, super important for your next test, you must know the quadrants for the graph. So quadrant 1 is where everything's positive. Quadrant 3 is where everything is negative. Okay, and let's see, would that be counterclockwise? I think so. Yeah, but it goes in a circle. It starts with quadrant 1, you go to the left, that's quadrant 2. You go down, that's quadrant 3. And this last one is quadrant 4. You must know these quadrants. You must memorize them for your next test. Okay, let's do some examples. Luckily, we don't need to go to Desmos because we've already put the graphs on the notes. Here we have an absolute value function with a couple of things we can notice. Here's the vertex right here. For all of these, the domain will be all real numbers because, once again, it goes forever to the left and right. Okay, and the range is going to be all the y values less than or equal to wherever the maximum is. So in this case, the maximum's up here at positive 4. So my range would be everything less than or equal to 4. The intercepts, I can see both of them right here. There is a y-intercept eventually down here, but we'll just go for the x-intercepts for now. Obviously, you could type this into Desmos and find that y-intercept. There's two of them. It crosses at -7, 0 and at -3, 0. Okay, so two x-intercepts. The axis of symmetry, well, we can draw it. This would be my axis of symmetry. Okay, and instead of x equals 0, this time my equation will be x equals -5 because we see the -5 right here, and that is where the graph is symmetrical. So x equals -5 is going to be my axis of symmetry. Okay, and then we have to find the maximum on these intervals. Let's see, between -8 and -4, well, the maximum is just going to be the maximum of the graph. The vertex is at -5, 4. So that would be my maximum, -5, 4. The minimum between -8 and -4 is going to be this point right here, the lowest point between those two values, and that is going to be -8, -2. Technically, I should say my answers are 4 and -2, since these are the y values for the maximums and minimums. Okay, for the next one, I'm just going to focus on the vertex. Okay, let's see. What quadrant is the vertex in? Well, if we label our quadrants, 1, 2, 3, and 4. Okay, we can see that the vertex is in quadrant 1. Okay, the domain, all real numbers once again. The range is going to be all the y values greater than or equal to, let's see, my y value at the vertex is 1, so it's going to be 1. My vertex is at 2, 1, which is why we get that range. And the axis of symmetry, this line right here, the axis of symmetry, is going to be x is equal to 2. And feel free to graph that on Desmos to prove that to yourself. I forgot to answer on this example 1, I forgot to answer what quadrant is the vertex in. That would be quadrant 2. Okay, let's see what else we can do. Okay, the most important part of this. Here's the general form. For this, here we have multiplication out front with the letter A. We have subtraction with an H and a K. Those H and K are actually going to be your vertex. So whatever those numbers are will be your vertex. So for example, f of x is equal to 2, absolute value of x minus 6 plus 4. The vertex would be at 6, 4. Okay, so you just take those two numbers, H and K, and they will tell you your vertex. Okay, the axis of symmetry is going to be x equals a number, and whatever that number is going to be h. Okay, if you just find out what h is in the equation, then you don't even have to go to Desmos. Let me show you what that looks like really quick on Desmos. Let's see. Right here. Okay, so we have the multiplier a in front. If we change a to be a different number than 1, we get wider graphs or more narrow graphs, or sometimes it'll flip upside down. Notice how when it's 0, the graph disappears. That's because anything times 0 is just 0. Okay, and if we make it 1, we can get the parent function. That's the dotted lines. Okay, so let's make this -1, and we'll see that it's a perfect reflection across that graph. If we move this back to 1, we can move around h and k, and you'll notice that this changes my axis of symmetry and the vertex. Okay, if we just move around k, this will not change my axis of symmetry, it will just move it up and down. Okay, so once again, h is left and right. If it's positive, it'll be over here. If it's negative, it'll be over here. Positive is up, negative is down for k. Here we have h, k, and then the axis of symmetry all graphed in 1. I will put this graph in a link in the description below. Okay, so let's take a look at this function right here. A ride at an amusement park carries passengers along a vertical tower to give them a view of their surroundings. During a test run, a park employee records the height of the ride for 10 seconds. Okay, the function f of x equals x minus 5 plus 4.8 models the height f of x of the ride in meters after x seconds. Graph the function in your calculator, interpret the domain, range, and intercepts, symmetry, maximum, and minimum. Okay, so first off, we already know the domain is all real numbers because it's an absolute value function, so the domain has to be all real numbers. But wait, we're talking about the real world. In the real world, you're not going to ride this roller coaster forever. In the real world, the range would be in between 0 and 10 because the most time that it will be is 10 seconds. That's how long it records. The range, we're going to have to go look on the graph for that because we need to keep our domain in mind when we look at the range. The intercepts, we can't really tell yet. The axis of symmetry, well, we can figure that out. Let's see, if f of x is equal to absolute value of x minus 5 plus 4.8. That means that the vertex has to be at 5, 4.8. Okay, and I don't even have to look at the graph for that. So that means that the axis of symmetry is going to be x equals 5. Okay, that will be my axis of symmetry, and we'll see that when we look on the graph in a minute. I can also tell that this is going to be positive, so it's going to have a minimum, not a maximum. There is no maximum. The minimum is going to be whatever the vertex is, the y value, so that's going to be 4.8. Okay, so let's go look at the graph, and then we'll be able to get the rest. So we're looking at the range first. Okay, the range, if we're looking between 0 and 10, looks like it's between the vertex, which is at 4.8, and the intercepts, which we have one at 9.8 right here, 0, 9.8. So that would be my maximum on this interval. For the range, it's going to be in between 4.8 and 9.8, because that'll be the same for 10 as well. Okay, so for the range, we would normally say y is greater than or equal to 4.8, but in the real world, the roller coaster does not go up forever. So we have to consider only between x between 0 and 10. If we consider that, then y has got to be in between 9.8 and 4.8. Okay, so just making that distinction between in the real world and if we're only considering this actual example. The intercepts, we saw one of them, just one, at 0, 9.8. Okay, and if we graph the axis of symmetry, we can see that that is going to work as well. Here's my axis of symmetry. Whenever it equals 5, it should be right in the middle and should be symmetrical, and it is. Okay, last one, or last two. Write an absolute value function that has a minimum in quadrant 3 of the coordinate plane. So here's the order. Remember, we have 1, 2, 3, and 4. Okay, so we want it to be in quadrant 3. So we want it to be in the bottom left. Okay, to do that, all we have to do is manipulate h and k to be exactly where I want. So we have absolute value of x minus h plus k. If we want it to be in quadrant 3, then we need this to be a negative. So let's do, for example, well, let's see what I did on Desmos. On Desmos, I graphed x plus 5 minus 5. So let's see what that does. And this is something that you can do in your calculator and just see what works. There's a lot of different answers that could be correct for this one. If we do this, we get h is equal to negative 5, because remember, my form looks like this, x minus h plus k. If you see a plus sign here, it means that h must be negative, okay, because a double negative makes a positive. And then we have k, which is at negative 5, which is negative 5. Okay, this will put the vertex in quadrant 3, because my vertex will be at negative 5, and any combinations of numbers could have done this. It didn't have to be 5. Okay, so this would be my answer for example 4, and you can always go to the graph to verify that. Okay, the last one we're going to do is we're going to write an absolute value function where the vertex is at 3, negative 4. I'll write h and k next to these right away. It says it has a maximum at negative 4, which means that it's going to be pointing down if it has a maximum. Okay, and then it's horizontally stretched compared to the parent function. So we want this to be kind of wide, or at least wider than the parent function. So we're going to try to stretch it out, and we're going to see what numbers work for that. The first thing I'll do is I'll realize that, okay, I can figure out what h and k are, but I'm going to leave a alone. We have h, which is 3, so I'm going to put x minus 3, and k, which is negative 4, so I'm going to put minus 4 at the end. If we type this into Desmos, we can start experimenting with values of a that are going to make this work, because we've already got the first two. We've got the vertex right there at 3, negative 4, and as long as we make a negative, we will get a maximum at negative 4. Let's go to the graph to see what that looks like. Okay, so here we have a is equal to 1. We can see that here's my parent function with the dotted line. We need this to be a maximum, so we're going to have to change a to a negative. Like, let's make it negative 2. Okay, we do have everything we need, except we can see that this is more narrow than the parent function, and our goal is to find something that is horizontally stretched compared to the parent function, so wider. To make it wider, we need to pick a number that's going to make it wider. So if we keep making a more negative, it's not going to help. But if we make a something like negative 0.5, we get something that is wider than the parent function, has a maximum at negative 4, and has the correct vertex at 3, negative 4. So it has all the properties that we need. So let's just do this one. So the way we would write it is f of x is equal to 1/2, negative 1/2, absolute value of x minus 3 minus 4. And this would have all the properties that we wanted. Okay, next up is going to be 2-4. Be looking out for that video. That one is going to include a lot more graphing and a lot more usage of Desmos. If you have any questions, stop by my room. It's SE211. This is Mr. Story signing out. Have a great day. Try to enjoy the little things for once. Okay, bye.